Hello everyone, this is Professor Chan for Math 1240 for the online class. I want to kind of go over some of the problems dealing with Chapter 6, okay? As some of you guys may know, Chapter 6 is going to become pretty difficult. Just also kind of a note to keep in mind is a lot of the chapters after Chapter 5 is going to get significantly harder, so make sure you practice these types of problems. You want to make sure you kind of practice these problems as you go along, and you want to make sure you know which method to use. So in statistics, you're going to be running into situations where you have to know a specific tool that you'll need for a particular problem. Okay, and we're going to talk more about this later. But the biggest one for chapter 6.1 and 6.2 is a concept of normal distribution. Okay, so now, if you have watched the PowerPoints, what Tyler does, he does it on his calculator. But the idea is you can also do this by hand. So let me show you an example right here. So we have a situation like the following, where it says we have a mean of 533. We assume it's normal, right? So normal means the following, right? It means that it is unimodal and it's symmetric. Okay, so the idea is I have a curve like this, and in the middle is 533, and it says a standard deviation 116. So each time I'm going to go up by 116. So I'm going to do 649, 765, and 881. And then I'll subtract 116 as I go along, right? So this is 417, and then 301, and then this is 185, okay? Right, so I have a curve like this. Again, just do your best. Okay. So it says, what percentage of scores were below 400? So let's talk about this. What is 400? 400 is approximately right here. Okay. And it says that it's below 400. So we're actually trying to find this area right here. So what I'm going to do is, if I'm going to do this by hand, okay, I'm going to use a formula. Z is equal to x minus x bar over s. So this is a formula that you have used back in chapter 3. Okay, so my observed score is 400. My mean is 533. And my standard deviation is 116. So 400 minus 533. Okay. When you do this, you want to kind of do this for the following, right? Subtract first, and then divide it by 116. And so I get negative 1.14. Okay, yeah, and you don't want to do it all at once. Do the subtraction first and then divide, and you'll have the following right here. Okay, now some of you guys are like, what is this negative 1.14? How does that help? How does that help me? Okay, in your textbook at the very end, towards the end near the appendix, you have something called a table. Okay, now if you have a hard time finding it, I just uploaded this to the chapter 6 discussions. So there's a bunch of different tables you'll use. Okay, so if you go to the third and fourth page, you'll see the table like this. Okay. So this is called a z-table, or a normal cumulative probability table. So what does that mean? This is a table in which you calculate the area underneath the curve. Okay, now one thing you want to keep in mind is, if you notice, right, it is shaded right here like this, okay? So here's the thing. Your table, let's talk about this. Your table actually goes to the left, okay? To the left of whatever your marking is, right? So the table always shades to the left, okay? And this is important. But yeah, always remember that table always goes to the left, okay? So my z-score is negative 1.14. I believe that's what we said. Yes, negative 1.14. So negative 1.14, how do I look it up? So if you look at your column right here, okay? So if I scroll down, negative 1.1 is right here, and then to find a 4, I go all the way up here, okay? I'm going to zoom out a little bit, okay? So your first two digits, yeah, so always round two places after digits, and then your first two digits will be in the column, will be in the row form, and then your last digit, or the second digit away from the decimal, will be in the column form. So notice I have negative 1.1 and then 4. I see where they intersect. So my answer here, according to my table, is 0.1271. Okay. And I get 0.1271, and that will be my final answer. Okay. Now, just kind of a recap, if you don't like this method, okay, if you don't like this method, you can use the calculator run, and just remember, how do we do this? We do second vars, and we do normal CDF. And so this is going from, so the way that you want to look at this is look at your drawing, okay? So if you look at this, this is going all the way to the left, right? It keeps going towards the left, okay? Remember this too, your area goes past the third standard deviation. So it doesn't actually stop at the third standard deviation to the left or right. It actually technically keeps going. It's just that it's very tiny, but it continuously goes off to the left or right. So, but you can also, right, use normal CDF, right? So you can do second vars, do the second option, okay? So lower we do negative 1 E. Remember how we do E is second comma, 99. And I'm going up to 400. My mean is 533. And my sigma is going to be 116. Okay. Sorry, I realized I did not draw the 116 here. Okay. So then I hit paste. I hit enter. Okay. Okay, for the most part, okay, and here's the thing too that you'll have to kind of realize. Sometimes your calculator version and then if you're doing it by hand will be a tiny bit different. If you're doing this on your homework, it should accept either one, okay? So if you're doing it by hand, or if you're doing it by normal, or if you're using normal CDF by calculator, it's fine, okay? Now remember, on your midterm, or sorry, on your final, if you're doing this by your calculator, you must show your work by writing what you see on screen. So if you're doing the calculator version, okay, you need to do it like this, right? You need to write normal CDF, and then you'll type in, and then you'll write your four numbers, right? Negative 1E99, 400, 533, and 116. And then you'll get the following. You're going to get, I think we got 0.1257. Okay. 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 Yeah, so there'll be a tiny difference, okay, but it should, as long as you show your work, it should be fine either way. Okay. Now, let me show you two more examples for this here. Okay. So we're going to do the same. So if you look at this problem here, we're going to do the same type of problem. We're doing number 2, and we are having, so the only thing different is the question's a little bit different, but my parameters are still the same. So I still have the following here. Let me go and copy this. Okay. That's not working, so let's just draw this out again. right? So I have 533, and I'm going up by 116 each time. Here's a tip too. If you're running out of time, you don't have to label all three of them out. You just want to do enough so that it's talking about the problem that you're doing. So it says above 650. So I'm just focused on this one right here. So I'm not even really worried about the left. Now let's look at this one. It says what percentage scores were above 650. Okay. So 650 is like right here. It's a little bit above 649. And we're going this way now. Okay. Let me zoom back in. Okay. So let's talk about this right here, okay? So we're still going to use our Z. If you're doing it by hand, you're still going to use your Z score. Okay. Which is Z is equal to, okay, X minus X bar over S. Okay, now let me talk about this before we move on, okay? So you actually have two different symbols for mean. So you have mean, you have X bar and mu. And then for, yeah, this is called mu, MU, that's how we pronounce it. And then your standard deviation, SD, we use sigma, or we use little s, and we also use sigma. Sigma is the one with the little tail, okay? We call this sigma, okay? So you'll see both of these symbols used simultaneously. Once we hit chapter 7, you'll understand kind of why we have two different ones, okay? But for now, both of those letters represent mean, X bar, mu, and then standard deviation are both represented by S and sigma, okay? So if I look at my formula here, X is my observed, so that is going to be 650, right? Because that's the score that's being asked. And then I have my mean is 533, and then my standard deviation is 116. So I throw this in my calculator. And I get 1.01. I'm rounding it to the nearest hundredth, so 2 places after decimal, I get 1.01, okay? Now, how do I calculate this one right here? Now, here's a thing to remember. Your table, if you look at your picture, normal CDF tables, okay, or so it's also called a Z table. Your Z table only goes to the left, okay? So 1.01, okay, so this right here, if I'm using my, right, so I know 1.01 is here, right, and I get this table right here. This is not correct. This is to the left. So 84.38% of is to the left of 1.01 according to my calculations. But the thing is, I'm being asked to calculate to the right. So if you look at your picture, right, my picture is going to the right. But if I look at the table here, it's going to the left. Okay. Now what do we do? Now remember, the area under your total curve is 100% or 1. So if I want to find the area, and since I have the right, I want to find the right area, or sorry, area to the right, what I'm going to do is in order to find the area, I'm going to do 1 minus whatever I got from my table. And the table that it gives me is 0.8438. So it's going to be the following. 1 minus 0.8438. Okay, so I throw it on my calculator. And I get 0.1562. Okay. If I want to do it, and so this is my answer. So if I want to do it on my calculator, however, the way I'm going to write this out is I'm going to do normal CDF, and I'm going, remember the word is lower, upper, and then mean and standard deviation. So lower is 650, upper is 1E99, my apologies, let me redo that one because we don't have a lot of room. Okay. So how do I calculate this? I'm doing normal CDF, $650, 1E99, my mean, which is 533, and then my standard deviation was 116, right? Because I'm going from smallest to largest, and then mean and standard deviation. So let's do this on the calculator. So I do second vars. Okay. And notice once again, you're going to be a tiny bit off. So notice I get 0.1566. And that is my final answer right there. Okay. So again, you will have some small differences between how to use it on your calculator versus how you're doing it by hand. Okay. Again, either one's fine. And then once again, if you're using your calculator, you must write what you're putting onto your screen. Okay. You can't just like throw in some random number and call it a day. Okay. You have to show your work for that. Okay. Now, let's look at one more example. Okay. So, let me zoom out here, because I'm going to draw the sketch again, okay? Make sure you practice sketching out your normal curves. So it's 533, 649, 765, 881. 417, 301, and then 185. So it looks like this right here. Okay, so if you're going from 400 and 700, so let's kind of draw this out here. Let's understand what's happening. So 400 is 700. Okay, if I had to guess, is like right here. So we're trying to find an area for this. Okay, this is kind of a trickier one. I'm gonna give myself some room for this one right here. Okay, so when you're doing this right here, let's talk about how we find an area. Okay. You're going to actually find two z-scores. So I have a z-score at 700 and a z-score at 400. Okay. Now let's kind of think about visually what's happening. So if I have the z-score at 700, right? 700 will look like this. Right? If I do z-score for 700, if I do the table for 700. If I do the table of 400, notice it goes to the left this way. So if I do 700 minus the 400, right? Notice what I'm doing. I'm actually kind of cutting this part out, right? This part doesn't exist. And look, it's very similar to what we have right here, okay? So let me repeat that again. I'm going to find a table of the 700, which goes to the left, and I subtract it by the table of the 400, and that goes to the left. So I'm going to do two z-scores right here. Okay, so I'm going to do the following. So this is for the 700. I'm going to do z is equal to x minus x bar over s. In our case, it's 700 minus 533 divided by 116. And I get approximately 1.44 if I throw this in my calculator. Okay, remember to subtract first and then divide. So let me look at my table. So remember, I'm doing the table and I'm going to the left, so I don't need to subtract it from 1. So z-score of 1.44 according to this. So 1.44, let's talk about this here. So 1.44 is 0.9251. So my table is 0.9251. Okay. Now what I'm going to do next is I'm going to do the same thing, only I'm going to do the table for the 400. So this is going to be 400 minus 533 divided by 116. And this is negative 1.14. So let's go back to the table. Oh, we already got that, so it's 0.1271. So my table for this one is 0.1271. Yeah. So how do I find out area of this? Right, so I'm actually going to do 0.9251 minus 0.1271. And this is 0.798, okay, as my area. Okay. I can also use my calculator, right? I'm going to do normal CDF, second var is normal CDF, okay? Make sure you follow the other one that Tyler has done, so you can get familiar with the calculator. But but if we're doing this one in a calculator, I look at here, right? And like my lower is 400, because it's smallest for the shaded part. Upper is 700. My mu, which is my mean, is 533. My sigma is 116. Okay. Notice when I enter this, very similar. Okay. For the following here. Okay. Okay. So let's take a look at the very last one here. And let me just view out, just so I can see this table again. So let's say you have a problem like this. So 533. Okay. I don't have time to kind of do the hash marks right now, okay? But let's just kind of do approximation, right? So 733, right, according to my situation, right, is approximately right here. and 333 is actually approximately like right here. Okay, so it says what percentage of scores are above 733 and 333. Okay, so let's talk about this here. So this is called a two-tailed symmetric problem, which means how do we know it's two-tailed and how do we know it's symmetric? Because if you notice, 333 is 200 away from 533, and 733 is 200 away from 533. So they're both, right, they're both equal distance from the center, and one is going, we're trying to find below 33 and above 733, okay? Now, because it's symmetric, let's just talk about this. What do we just do? All we need to do is just find an area of one of them and then double it, and that's our final answer, okay? So all I'm going to do is do this, right? I'm going to just pick one. So let's pick the 333. So I'm going to do z is equal to 333 minus 533 divided by 116. Okay, and I get approximately negative 1.72. Okay, so according to my table, I go back up here, negative 1.72 is 0.0427, right? I'm looking at O2, negative 1.7, and in the center, sorry, let me zoom in. Right, it's 0.0427. Okay, so my table says it is 0.0427. Sorry, let me just double check. 0.0427, yep. Okay, but since it's two-tailed, I'm just going to multiply it by 2. So I do 0.0427 times 2. And I get 0.0854. Okay. So let's talk about normal CDF here. So if you're calculating it by hand, okay, so let's talk about what happens here. So if you're calculating by hand, the rule is if it's less than, your percentage is your table. Okay. If it's greater than, your table is going to be, your percentage will be 1 minus the table. If it's in between, right, it's going to be table of the right, or we can say table of the larger, minus the table of the smaller. And if it's two-tailed, your percentage is going to be either 2 times the table of the left or 2 times the table, 2 times one minus the table of the right, okay? Now, we didn't do that one there, right? The one we did was 2 times the table of the left. So I took the left side, right, which is my table, and I double it. If I'm doing the one on the right, I need to subtract that from 1, because remember, your table always goes to the left, okay? Okay. So let me zoom in. or a better way is, sorry, for the third one is the following. Table of the right minus table of the left. Okay? So each problem, the first problem dealt with the less than, the second problem we did was the greater than, the third problem was in between, and last one was a two-tail. Okay? So this is how we do normal CDF here for the following. Okay? But that's how you do stuff from 6.1, 6.2. If you have questions, let me know. I'm going to upload some other ones shortly. Okay?